For months, the solar system's most mysterious guest played a dangerous game of hide-and-seek with our sun, and what we discovered when it re-emerged has rewritten the rules of interstellar travel. This object, designated 3I Atlas, is not a native of our cosmic neighborhood. It is a wanderer, a voyager born in the disk of another star untold billions of years ago, now screaming through our celestial backyard on a one-way ticket back to the galactic dark. Its very presence is a staggering statistical gift, a fleeting chance to directly sample the building blocks of a world formed around another sun. But as we trained our telescopes upon it, this visitor began to behave in ways that confounded our expectations and ignited our imaginations, presenting a puzzle that deepened with every new observation. The story truly picks up in the critical window of October. As 3 Atlas dove toward its blisteringly close solar encounter, a cosmic coincidence robbed Earth-based astronomers of their view. The comet vanished, hidden directly behind our star's overwhelming, blinding glare. Imagine the profound frustration. The most exciting moment in the object's journey, where solar heating would be at its maximum, triggering violent and revealing outgassing, was happening on the far side of the very star that powered the show. Ground-based observatories, which had been meticulously tracking its every move for months, were suddenly rendered useless at the worst possible moment. We had only just begun cataloging its bizarre traits, its perplexing shifts in color, its strange molecular ratios that didn't quite match our own comets, and that peculiar spike of material, an anomalous jet pointing not away from the solar wind, but defiantly toward the sun itself. Then, it was gone. The visitor was subjected to the star's furnace-like radiation, with temperatures soaring into the thousands of degrees, all while traveling at a heart-stopping 68 kilometers per second. A simple, ominous question hung in the void. Would it survive this trial by stellar fire, or would it be vaporized into a cloud of insignificant dust? Fortunately, our perspective is no longer limited to a single planet. Earth was not the only vantage point. A silent, robotic fleet of eyes, strategically scattered across the inner solar system, was perfectly positioned to watch the spectacle unfold from the other side. Solar observatories, planet-orbiting probes, and even robots on Mars turned their sensors toward the event. Their data has now streamed back to Earth, and it paints a picture of an object undergoing a profound and violent metamorphosis. The signals we received before the blackout were already hinting at this bizarre reality. NASA's Swift satellite, an instrument usually tasked with hunting the most powerful explosions in the universe since the Big Bang, caught 3I Atlas in its ultraviolet gaze. What it saw was extraordinary. A torrent of hydroxyl molecules, the shattered pieces of water ice. The shocking part was the distance. At a point where most comets are still dormant, frozen solid in the deep chill of space, this interstellar visitor was dumping water into the vacuum like a relentless cosmic geyser. This wasn't a normal, gentle sublimation. It hinted at a chaotic, fractured, grain-rich structure that was violently shedding material from the very start. Then, as if on cue, the sun intervened, pulling a curtain across our view. On the far side of that curtain, our dedicated space-based solar observatories, Stereo A, SOHO, GOES 19, performed a unique pivot. They turned their coronagraphs, instruments designed to block the sun's brilliant face to study its stormy atmosphere, away from solar flares, and toward the passing comet. They became comet hunters. What they witnessed was a dramatic acceleration of activity. The comet's brightness, which had been increasing at a steady and predictable rate, suddenly skyrocketed. The slope of the brightening curve went nearly vertical, a telltale sign of ferocious, almost explosive activity. The sun's intense heat was not just warming the surface, it was aggressively peeling the object apart, layer by layer. Furthermore, through the specific filters of these instruments, 3I Atlas underwent another color change. To these space-based eyes, it glowed with a distinct and telling blue hue. In the lexicon of comet science, blue is the specific fingerprint of certain gases, particularly carbon monoxide and amide radicals fluorescing under the solar ultraviolet barrage. The data suggested the red, dusty cloak it had worn for millions of years, perhaps even billions, was being burned away in the stellar inferno, revealing a far more volatile, gas-rich engine beneath the ancient processed crust. Simultaneously, a fortunate cosmic alignment provided a second unique perspective. On its inbound plunge, 3i Atlas made a relatively close pass by our neighbor, Mars. This was a gift of orbital mechanics, offering the fleet of robots we have stationed there a front-row seat. Every available asset took aim. Orbiters like NASA's Mars Reconnaissance Orbiter and ESA's Mars Express swiveled their high-resolution cameras. The greatest hope rested with the high-rise camera on MRO, an instrument so powerful it can resolve a kitchen table on the Martian surface from orbit. Surely this would finally deliver a clear, resolved picture of the comet's elusive nucleus, allowing us to measure its shape and topography. The images, delayed due to the complexities of data prioritization and transmission, were finally released. The result was, to the public, underwhelming. A fuzzy, unresolved blob. Even from just tens of millions of kilometers away, the core was hopelessly shrouded in a vast, brilliant coma over 1,000 kilometers wide. While no detailed portrait emerged, this non-detection is itself valuable scientific data, helping researchers constrain the nucleus size by measuring how deeply it was hidden. More poetically, NASA's Perseverance rover, sitting in the ancient river delta of Jezero crater, looked up through the pink Martian sky. Its Mastcam-Z camera captured a long exposure image, a faint ghostly smudge among the stars. This humble image is groundbreaking, the first ever photograph of an interstellar visitor taken from the surface of another world. Then came the moment of truth, perihelion, the point of closest approach to the sun. As 3i Atlas emerged back into Earth's view in November, a wave of anxious speculation rippled through astronomy circles and online forums. Had it shattered? Rumors of fragmentation spread, fueled by the extreme brightness surge observed by the solar probes. The logic was compelling. Could such violent, sustained outgassing provide enough thrust to alter its trajectory, without ultimately tearing the fragile nucleus to pieces? For a tense period, it seemed our chance to study this rare visitor might have evaporated just as it reached its peak activity. However, new observations from powerful ground-based telescopes like the Virtual Telescope Project provided clear relief. 3i Atlas was, against some odds, intact. No debris train, no chaotic cloud of fragments followed it. The explosion was merely that, an explosive, yet entirely natural shedding of its processed outer layers. The nucleus had weathered the storm. This survival, however, directly fueled the million-dollar question that had shadowed this comet since its unusual characteristics were first noted. Are we absolutely certain it's a natural object? Prominent figures in the scientific community, most notably Harvard astrophysicist Avi Loeb, had consistently pointed to tantalizing anomalies. That persistent sunward-pointing jet, to some eyes, resembled the directional plume of a thruster. The object's seemingly non-gravitational acceleration, changes in its speed not explained by gravity alone, appeared remarkably smooth and constant, almost like a controlled burn. Loeb and others argued that the sheer force of outgassing required to produce such an acceleration profile would be immense, potentially enough to disintegrate a loosely bound icy body. Could this, they wondered, be evidence not of geology, but of technology? Could 3i Atlas be a derelict light sail, or a purpose-built probe? As thrilling as that hypothesis is, the weight of evidence has steadily built a robust and comprehensive natural explanation. That enigmatic, sunward jet is a known, albeit uncommon phenomenon in comet science. It can occur when a comet's nucleus has a particularly weak spot or active vent directly facing the sun. Gas and dust can erupt directly sunward before being swept back and sculpted by the solar radiation pressure into a curved or spike-like feature. We have witnessed similar structures on famous comets like Halley and 67P Churyumov-Gerasimenko. The non-gravitational acceleration is textbook cometary physics, the rocket effect. As gases erupt asymmetrically from the rotating nucleus, they provide a tiny but cumulative thrust, subtly altering the orbit. Sophisticated new trajectory models have now confirmed that 3i Atlas's motion is perfectly consistent with the colossal amounts of gas and dust we have directly observed it releasing. Most decisively, a recent observation from the Meerkat radio telescope array in South Africa has effectively closed the case for an artificial object. Radio astronomy provides a different sense than optical light. Meerkat detected a faint but definitive signal at specific frequencies, the precise radio wavelength absorption signature of hydroxyl radicals. This is the unambiguous calling card of water vapor. Unlike visible light, radio waves can penetrate the thickest dust clouds, offering a direct probe of the gas enveloping the nucleus. This detection confirmed the presence of a vast, extended envelope of water vapor. A dry, metallic, artificial probe, a piece of refined technology, would simply not produce this signal. The verdict from the universe itself is in 3I. Atlas is a comet. But in declaring it a comet, we must be careful not to mistakenly label it as ordinary. It is an exceptionally weird, profoundly alien comet. Data from the James Webb Space Telescope and other infrared observatories has revealed its most stunning compositional secret. It is utterly dominated by carbon dioxide. The ratio of CO2 to water is staggeringly high, about 60 times greater than the average for comets native to our solar system. It is, in essence, a dry ice bomb. This immediately raises a profound question. Where did this incredible abundance come from? A groundbreaking new theory, led by researchers like Romain Maggiolo, provides a fascinating answer. The explanation lies not in its birth, but in its epic journey through the interstellar medium. For billions of years, as 3I Atlas drifted in the profound cold and emptiness between stars, it was not in a passive environment. It was under constant bombardment by galactic cosmic rays. High-energy atomic nuclei accelerated to near-light speed by supernovae and active black holes. This relentless radiation, penetrating meters deep into the icy body, acted like a slow cosmic irradiation oven. The process, over eons, transforms simple ices. It chemically cooks them, breaking apart water and carbon monoxide molecules, and reforming them into a thick, complex crust rich in carbon dioxide and refractory organic sludge, a tarry substance sometimes called radiolytic crust. What we are witnessing now is not the sublimation of a pristine, primordial ice ball from another solar system. We are seeing this radiation-baked, billion-year-old outer shell being violently stripped away by our sun. The comet isn't newborn, it is deeply weathered, a traveler carrying the irreversible scars of its marathon journey through the galactic dark. This cooked nature itself may be the key to unlocking its other strange behaviors, including its dramatic brightening surges. Spectroscopic analysis suggests the comet contains significant traces of metals like iron and nickel, similar to those found in certain rare primitive meteorites on Earth, called carbonaceous chondrites. This introduces a potent catalyst for volatility. Scientists propose a compelling engine for its activity: cryovolcanism driven by exothermic chemistry. As sunlight finally penetrates the porous cooked crust and begins to melt buried water ice, that liquid water comes into contact with these scattered metal grains. In the presence of such metal catalysts, water and carbon compounds can undergo Fischer-Tropsch-type reactions. Crucially, these reactions release heat. This creates a powerful feedback loop. The reaction heat melts more adjacent ice, releasing more water to react with more metal, generating more heat. Pressure builds in subterranean pockets until the overlying crust can no longer contain it, rupturing in a violent cryovolcanic jet of gas, dust, and water vapor. This could perfectly explain the sudden, explosive brightening events, the peculiar jets, and the massive episodic release of material that so puzzled observers. It paints a picture of a chemically reactive, geologically complex world, not a simple, passive ball of ice. So, where does this remarkable messenger go now? It has survived its trial by solar fire and is now racing outward, on a hyperbolic trajectory that will inevitably carry it back into the interstellar abyss from whence it came. But its interaction with our solar system is not quite complete. In March 2026, it is predicted to pass relatively close to the gas giant Jupiter. While moving far too fast to be captured, the planet's immense gravity will give the comet a final, gravitational nudge, a slight bending of its path as it bids farewell. This flyby offers a tantalizing final opportunity. If NASA's Juno spacecraft, currently in orbit around Jupiter, is still operational, and its instruments can be pointed in the right direction, we might secure one final, distant snapshot, a farewell glance of the visitor from the outer solar system as it begins its eternal departure. The saga of 3I Atlas has been a masterclass in 21st century astronomy, showcasing global collaboration, multi-wavelength observation, and rapid scientific analysis. It is not an alien artifact, but in many ways, it is something just as profound and perhaps more meaningful. It is a physical messenger, a postcard from the galactic processes that shape all planetary systems. Its altered, cooked chemistry tells us the space between stars is not a gentle, empty void, but a transformative radiation field, that processes matter over astronomical timescales. Its survival demonstrates the unexpected durability and geological complexity of these small, icy worlds.
It reminded us that our first assumptions about visitors from afar can be wildly mistaken, and that nature, when studied in detail, is always more inventive than our fiction. It leaves us with a humbling and exciting truth. The galaxy must be filled with such travelers, countless billions of them, each a silent, scarred witness to the history of its own birth star, and each carrying, in its chemistry, the rewritten story of an epic, billion-year voyage through the dark. If you found this deep dive into our latest cosmic discovery fascinating, help us share these stories of exploration and understanding. Please give this video a like, and subscribe to Winds of Thought to join us as we continue to unravel the universe's greatest mysteries, one observation at a time. What do you think will be the next great interstellar surprise? Let us know in the comments below. Thanks for watching.